This is our car project. It has multiple features, which are automatic braking, a keyless entry, and warning indicators, and it has also power mirrors. The first thing we need to do is to unlock our car using the RFID. The buzzing indicates that we successfully unlocked it. The next step is to start the engine using the start engine button. Now the car started up. The LCD indicates that the seat belt is off. So we need to put on our seat belt, which is represented as a button. So we will fasten the seat belt. The buzzing stops. The buzzing used to indicate that the seat belt is off, and the change is indicated on the LCD. The next feature we have is power mirrors, which is represented using a servo motor, and it is controlled using a joystick. So we can control the mirrors in two directions, either to the left or towards the right. We have an ultrasonic sensor at the front of the car, which causes a buzzer to sound when it's near an obstacle. Now it was buzzing because my hand was in front of it. So this indicates when the driver is about to hit an obstacle, and this is one of our warning indicators. Our car has some sensors. We have a rain sensor right here, and if we add some water to it to simulate rain, the LCD changes indicating that it is raining, and once the rain stops and the sensor dries, it changes again to indicate that it has stopped raining. The other sensor we have is a fuel sensor, fuel level sensor, which is done with a water depth sensor. First off, the sensor is not touching the water, so it indicates that the fuel level is low. Once we put a bit of it in the water, the fuel level is medium, and if the tank is full, then it indicates that the fuel level is high.
Hi, my name is Free, and I have really enjoyed working on this project. Throughout the semester, I have worked on multiple parts, mostly software related, especially the artificification part, as well as other functionalities of sensors, like the ultrasonic sensor. I worked to make sure that when it detects an object at a distance less than the clear distance, the car immediately stops. I have also worked to make sure that the Bluetooth module functions properly and receives proper signals to make the car move as directed. Now, during the artificification part, I have struggled with separating code into individual tasks. I have tried not to under-separate or over-separate, but in the final stage, many of the tasks were grouped together to ensure that we fulfill all the deadlines and that the watchdog timer is not kicked. The final result concluded that about 4 or 5 tasks hit the point. More than that, and we risk running out on deadlines. Less than that, and we group unrelated features together. So that is what we settled upon.
The servo motor is connected to the 5-volt output and the ground of the Arduino. It's also connected to a digital output pin, which controls its motion. The servo is controlled by the joystick here, which is connected to the voltage and the ground also, and it's connected to an analog input pin, which takes the analog data from the joystick and converts it into a specific voltage to move the servo motor. The LCD is connected to the voltage and the ground. It has 6 control pins, and it's also connected to an analog output from the Arduino to control the contrast. We did this instead of using the potentiometer because we don't care about adjusting the contrast on a car display, and the contrast is always constant. We also have a buzzer. This buzzer is connected to a resistor and to a digital output from the Arduino. It indicates when the seat belt is not fastened. And we have a second buzzer here, which is connected the same way and beeps whenever the car is about to hit an obstacle. The last thing we have is the two sensors. We have a water depth sensor, which is connected to an analog input pin on the Arduino and connected to the voltage and the ground. We're using it to measure the fuel level. And we have a rain sensor. The rain sensor has two options, either digital or analog. Since here we're only using it to tell whether it's raining or not, we opted for the digital option. The analog option could be used to tell the rain intensity. But here we just connected the digital pin to a digital input pin on the Arduino, and we connected it to the voltage and the ground.
Hello, my name is Omar and this is our car. I'm going to talk more about the movement part and how it's implemented. So first of all, we are having two power sources. The first one is this power source, which is almost 12 volts. The other power source is 9 volts. The first power source is powering the motor driver and the second one is powering the Arduino. So how the car is moving, we are having a Bluetooth module which receives the signal to move the car from the application. Mainly the car can move in two directions, either in front or back. We also have an ultrasonic sensor which give an audible sound if there is an obstacle in front of it, and it also stops the car. So this is an automatic emergency braking feature and how it's implemented along with the movement part.
My name is Mohammed and I'm gonna show you the keyless entry feature. To implement this feature, we use two components, the RFID module and the start-stop engine button. First, nothing is displayed on the LCD and we want to work on our car. We will scan the RFID module with our key. Then we need to press our button. The LCD is working and it shows that the seat belt is not fastened. We need to press this button to put on the seat belt. The bus is stopped and that means that the seat belt is on.